Hello friends, welcome to my channel with Study Dham Expand Your Horizon. We are going to learn about how the earth was formed. Let's begin. The earth is the third of the 8 planets that orbit the sun. Yes friends, I have said 8 planets because Pluto is no longer a planet. It is considered as a dwarf planet in a Kuiper belt. Guys, do you know where the name Pluto comes from? Wait, I tell you. Pluto got its name from 11-year-old Vanessa Burney of Oxford, England, who suggests to her grandfather that the New World get its name from the Roman god.
Hi friends, do you remember? Our topic is the Earth and we started talking about the Pluto. So, let's go back to the Earth.
Our Earth is the only planet that has life. But do you know how life on Earth become possible? Watch this video to know in detail. Let's start the incredible story of how the Earth was made. Here, the formation of Earth is described in 4 steps. Firstly, the formation of the nebula takes place. Second, the Earth was formed from colliding rocks. Third, the surface cooled to form Earth crust. Fourth, continents broke up and reformed, gradually moving to their present position. Let's start the brief explanation of the formation of Earth. 4.6 billion years ago, the solar system formed from a cloud of rock ice and ionized gas. This cloud is known as nebula. The cloud forms a disk of material around the young sun equator. The disk material struck together to form planets. Do you know the electrostatics and charge exchange between particles do occur in photoplanetary nebula? This means that charge exists in nebula. And because of this, rocks are attracted toward the nebula and form a giant round ball of boiling liquid rocks and metal. There are virtually no solid surface, just an endless ocean of lava. Experiment. How did the stones aggregate to form the planet? In 2003, astronaut Patty accidentally solved the paradox about the formation of planet. The experiment is small salt grains aggregate to form centimeter-sized structures in seconds when left alone in microgravity in the plastic bag. These aggregated salt grain centimeter structures are much stronger than one might assume. As I said, charge exists in nebula and because of this it attracts stones toward itself. Similarly, by touching the bag, electric charge is imparted onto the system and the salt particle immediately react. This implies that electrostatic might be the reason for the reaction that I told you earlier. So this is how our big rock fireball is formed. 4.5 billion years ago, the surface cooled to form the crust. 3.8 billion years ago, the period of late heavy bombardment, which brought water on the young planet Earth. It is believed that the most likely source for the Earth's water is a type of meteorite called a carbonaceous chondrite. Chondrite is just the name given to the class of stony meteorites that most commonly strike the earth. But only these meteorites contain water as well as a lots of carbon, because they are found out beyond the frost line of the sun. At first, the earth had only its landmass. When the water came on the earth, at that time the stage was set for the development of life. But the atmosphere was mostly nitrogen, carbon dioxide and methane. The prevailing hypothesis is that volcanic vents deep under the sea were spewing very hot chemically rich compound into the ocean, which lead to the first microbial organism that spread throughout the oceans. The oceans were populated by anaerobic microbes. Those are simple single-celled microorganisms lacking a cell nucleus that thrives without oxygen and use sulfur to obtain energy. But somewhere between 2.5 and 3.5 billion years ago, one of these microbial species, probably floating on the surface of the ocean, evolved a new ability, photosynthesis. The structures in their cell membrane could harness the energy from sunlight to turn carbon dioxide and water into oxygen gas and sugar, which they could use for energy. Those organisms were the ancestors of what we now call cyanobacteria. Photosynthesis gave those ancient bacteria huge advantage over other species. They could now produce their own energy from an almost endless supply of raw ingredients, so their population exploded. And they started flooded the atmosphere with oxygen, a byproduct of photosynthesis, which resulted the Great Oxidation Event, in which the entire planet freezes into a snowball Earth by stripping the greenhouse methane from the air. While oxygen-rich air was poisonous for many species. But thanks to the volcanic eruptions, which spewed CO2 in the atmosphere and warmed the climate, which led the white planet turns to blue again, because of which new life flourised in the oxygen-rich atmosphere. Ancient oceans and continents. 2 billion years ago, PANGEA broke apart and eventually formed 7 continents. By about 2 billion years ago, these supercontinents began breaking up. Over millions of years, PANGEA separated into pieces that moved away from one another. These pieces slowly assumed their position as the continent we recognize today. Plate tectonics began around 3 billion years ago when the first continent was formed. But here I only show you how Himalayas was formed by plate tectonic. The Himalayan mountain range was formed as a result of the uplift collision between Indian plate and Eurasian plate. The Himalayan mountain range began 50 million years ago and continues today. This Earth is our only home. It is unique among planets in our solar system for having water in liquid form and to enable life. The Earth gives us food, shelter, air, and basically everything we need to survive. In order for Earth to survive, we must keep these things alive and work with it to be a part of it, to be in harmony with where we live, not against it. %70 of the Earth's surface is covered by water, but 91% of the Earth's water is salt water and less than 3% is fresh water. Of that 3% of fresh water, over 68% is frozen in ice caps and glaciers. Over 31% is found in groundwater and only 0.3% is found in surface water. So please save water. The surface of the Earth is covered by rocks and water bodies, but what about the inside of the Earth? If we were to take a look at the Earth's interior, we would see that the Earth consists of 4 layers. They are the inner core, the outer core, the mantle, and the crust. The crust is the outermost layer of the Earth. It consists of various landforms like mountains, plateaus, volcanoes, etc. The crust also consists of numerous rock plates. The shifting of each plate results in the formation of the continent. In reality, the crust of the earth is very thin layer. It is only 50 km deep. The crust floats on the top of the outer layer of the earth. The oceanic crust is thinner than the continental crust. The mantle forms the main mass of the earth. The mantle is the layer just under the crust. It has a depth of about 2,900 km. The mantle is the partially molten layer and can have temperature reaching to 4,000 degrees Celsius. The upper layer of the mantle is called the asthenosphere. In addition to the asthenosphere, there is a layer known as lithosphere. The crust and the uppermost layer of the mantle together form lithosphere. Asthenosphere has a depth of 400 km and lithosphere extends from 10 to 200 km. The next layer of the earth is the outer core. This layer is extremely hot. It has a temperature of about 5,000 degrees Celsius. The outer core consists of mainly liquid iron. It has depth of 2,200 km. We now come to the innermost layer of the earth, the inner core. The inner core has a temperature of around 6,000 degrees Celsius. This is nearly the temperature of Sun's surface. The inner core has a depth of 1,250 kilometers. Unlike the outer core, the inner core is in solid state. The intense pressure of the layer of the earth ensures that the inner core remains solid in nature. Deep within the earth, there are radioactive elements such as uranium. These elements give off heat when they decay. This slows down the rate of which the earth is cooling. But the core also has a very important function. It is responsible for the magnetic field of the earth. The magnetic field is generated in the inner core and the convection within the outer core result in the creation of magnetic field. This magnetic field is what protects us from solar wind and high energy particles of the sun. The four layers of the earth all have special functions. Now you know what the earth's interior look like. Now the next question arises, how does the earth generate its magnetic field? Fundamental observation, only three ingredients are necessary for magnetic field generation. First, large electrically conducting fluid in planetary interior. Second, energy supply. Third, planetary rotation. Our Earth's magnetic field is believed to be generated deep down in the Earth's core. To know how is the Earth's magnetic field generated, we have to be familiar with the convection process. Convection is a process that moves heat around. Hot material comes up and cold material goes down. And in the interior of the Earth, convection occurs throughout the Earth's outer core and mantle. Mantle convection causes tectonic plates to move around the Earth's surface, and outer core convection generates Earth's magnetic field. Now you know the difference between both convection. So we know that the Earth's magnetic field is formed due to the outer core convection current, but how? So let me first mention that the Earth's outer core is a hot liquid iron alloy and the inner core is probably solid nickel iron and much hotter than the outer core. The heat from this inner core causes material in the molten outer core and mantle to circulate in convection current. These convection currents are caused by heat escaping from the core, a natural process called a geodynamo. Because of Earth's spin, there is a force that is stabilized called Coriolis force, which causes swirling whirlpool here too. Similarly, core flows are also greatly affected by rotation. The inner core is super rotating in an easterly direction and the outer core is flowing much slower in a westerly direction. This flow of molten metal produces electric current which generates self-sustaining magnetic field. And as a result of Coriolis force, all these combined effects add up to produce one big magnetic field engulfing the Earth aligned in one direction. The last important point to be noted is the Earth takes 365.25 days to revolve around the Sun. This is known as one Earth year. And in one rotation, Earth takes 23 hours and 56 minutes. Thank you for watching the video. Please like, share and subscribe to my channel.